In this video, we're going to look at RETScreen software from Natural Resources Canada. This software has been out for a number of years and can help do some pre-screening analysis for different renewable energy projects. We're just going to sort of tap into it. Unfortunately, Natural Resources Canada has removed a lot of their older archival information, which included tutorials and examples and lots of support for RETScreen. And the only thing available right now is to download the program, and then I guess they're expecting you to take courses or whatever to learn how to run it. But I just wanted to do a little bit of an overview of the RETScreen to make you aware of the program, and also to help you in being able to complete assignment 3.2, because RETScreen can be a little complicated without some guidance. So the first thing we need to do is to start the RETScreen, and it'll be on either on your desktop or the programs under RETScreen International. There are two programs when you install the suite. One is the RETScreen 4 and the other is the RETScreen Plus. We're not even going to get into the RETScreen Plus software, which is an energy management software, window-based. We're going to use RETScreen 4, which actually rides on top of, it's a set of macros within Excel. So you need to have a Windows computer, you need to have Excel loaded on that computer, and you also have to have the macros enabled. So when you start it up, if you do get an error, it'll ask you to allow macros to run on your computer. You need to say yes to that and hit allow. When you open the screen, it starts here, and there are a couple menus. There's tabs at the bottom. One's the start menu, the other is the energy model, and then a tools area. We're going to use the start to set up our project and then look at the energy model. So at the start screen, you can see that you can put some titles and stuff for your project. You can have a lot of different kinds of analysis, including energy efficiency measures, but maybe you want to do a power project, and you maybe choose something like photovoltaics. Within the photovoltaics, you can have a central grid connected system, or you could change this to an off-grid system, and there's a couple different methods with different levels of detail in the analysis. Also located at the bottom, you can select your location. Sometimes it's easier if you start with sort of a template and then adjust the project to your specifics. And for assignment 3.2, it's an off-grid system in Kamloops, BC, or in that area. And in that one, it might make sense to use an off-grid template. And so you can find these templates under the project database tab at the top, the little icon at the top. If I go to the project database, and there are templates for different projects which can help you get started, or there's case studies. For us, what we're going to do is we're going to use a case study which will kind of fill in all the numbers, and then we can adjust the numbers for our specific case. So we're going to go to the case studies, and we're looking at a power project in assignment 3.2 that is a power project, not a hydro. It's not hydro, it's photovoltaic. And the one we're going to use is the one for under Muskoka Airport, climate data, and it's a residential 0.3, only a 300 watt off-grid system, so a small cabin off there. And that seems to be a good starting point for us. Hit the check mark to accept that project, and it should reload all the data from the example project into RETScreen, and then we can go from there. So you'll see that it's now a photovoltaic system and an off-grid. They're using method 1, 0.3 kilowatt. We can change our project name here to assignment 3.2 for RC205 or something like that. You can fill in the rest as you choose. The first thing that you're going to do is need to change the location. It's not in Muskoka in Ontario. We're in Kamloops, BC, so we select climate data location. That's going to bring us up this table, and we can get the NASA data for BC, British Columbia. So we search quickly here, find BC, and we're looking for Kamloops. Kamloops Airport. And you'll see that the data is changed. Of course, the most important stuff for us are the daily radiation horizontal, and it'll also do calculations for tilted and stuff. So hit the check mark to accept that, and now all the data is in the Kamloops. You can check this show data part here, and a little bit below it will give you the detailed data, the relevant stuff that you need, heating degrees, degree days, shoulder radiation, wind speeds, and things like that for this project. So the next thing you do is, according to the assignment, would be to just change some of the parameters within the energy model to make that work. So as we flip to the energy model, there's a base case. So the base case is what you're comparing your proposed case to. What we want to compare it to is, what if I hooked it up to the grid? It's going to cost me a connection fee, a monthly fee, and electricity on the grid. So the base case is what would I do instead of the solar PV. So I'm going to do grid electricity. My fuel rate in the assignment, I think, was 13 cents. And what happens is I've got my num block on. So make sure you're entering in your numbers lock. The capacity here of the base case doesn't matter because it's grid electricity, so that's gonna give you a little bit of space there. You don't have to enter any operating maintenance. That's part of the included costs of that electricity, and you're there. So what you do need to do, though, is a little bit below that. You have the load characteristics. So you have to define the load characteristics for your assignment, and in this assignment, we said that we would be using 4 kilowatt hours per day. Now we're using it in the base case and we're using it in the proposed case. There's no difference. We need 4 kilowatts of electricity whether we're using it from the grid or from our proposed solar PV system. Apologize for all the noise. The other thing too is you can select what months you're actually out there. This is an off-grid kind of cabin, and I think in our assignment we said that we would include April all the way to September, and I'm saying we're going to use 100% of our 4 kilowatts in those occupied months, and then the other ones we're just going to call it 0. Now that's going to set me up. You'll see now that the total electricity costs are filled in. So for a 4 kilowatt load, you'll be using about $95 worth of electricity, and it calculates a bit of a peak load and the annual AC electricity charge. So then you slide down and you look at other kinds of things. You start changing. In the assignment it said that we're going to use a 6 kilowatt inverter, and the inverter is going to be, say, $3,500. Follow the assignment, the numbers in the assignment. Efficiency 90% is reasonable for an inverter. The battery, in this problem, we also want 2 days of autonomy. That means you can run on the batteries for 2 days. Efficiency of the battery 80%, depth of discharge 50. 50 is okay. Some people might want to discharge less than 50 to make your batteries last that little bit longer. But with these parameters, RETScreen will calculate this 400 number, which kind of estimates the amp hour size of the battery that you need, and the default, what's entered in here is 220, which is wrong, so we're going to put 400 in there because we will need 400 amp hours to supply the electricity that we need. And in the problem we said that these batteries would cost us $2,900, so the incremental cost of the battery is $2,900. So as we slide down now, we see that we can change the tracking method to fixed or single or double axis tracking. In the example for assignment 3.2, where it's going to be fixed, and we're going to set this slope to 50, and 0 degrees would be straight south, and you'll see that the tilted radiation gives you values for straight south, but In our particular example, our house isn't really oriented that way. It's minus 30 degrees, which is 30 degrees to the east. And as I click this, you'll see that the daily totals will change. And that's going to change your parameters of the solar system. Next thing you need to identify is the solar photovoltaic cells that you're using and the cost for those. There is a product database at the right here. And if you open the product database, you'll see that there's a lot of different manufacturers here. And for the assignment, we said we'd choose the Shot Solar, and we'd choose the 300 series, which are 285 watt module. And we're going to select 10 of those for our system. Oops, there we go, 10 system. So I hit accept, and then it populates all the cells with the exact parameters from the data sheet for that photovoltaic cell. Now the other thing is we said that this would now cost us $1 per watt for modules, so it's going to be $28.50 for the module cost. So we add that in this column that's called incremental costs. Calculations will automatically be done for the greenhouse gas emissions, the CO2 saved, and you can do that, or you can hide the emission one if you want, just to make it a little simpler. Then you get into the financial parameters. For this assignment, you can use a 2.5% inflation rate. It's probably closer to 2 maybe. It's going to change your parameters. Project life, you can do your analysis for 25, 30 years. 25 is a good example. If you choose a debt ratio of 0, it means that you're going to pay for this system outright cash. If you choose a debt ratio, I think the assignment suggests 50% will be on a loan. It will give you some loan parameters. And for this assignment, we're going to use 5.5% interest for a 5-year loan. And you'll see that as I make these changes, the profitability graph at the right changes. It shows me the break-even analysis real time, and I can make changes, what-if kinds of scenarios here. The total cost of the power system is the accumulated of all the incremental costs for the modules and inverter that we entered earlier. If the assignment, I think, said that there would also be a $3,000 additional installation costs that you have to deal with. So from this analysis, then, I'm going to select the OEM cost at 0 for now. What this is going to calculate for me is a total system cost of $12,000, 50% down, so that's why it's like $6,000 right off the start. And then we're going to take a loan, so we're going to make loan payments, so we're going to be losing money, and then we're going to start gaining money at the rate of $95 a year for the electricity that we've saved. However, when we're actually doing this analysis, there's actually a saving, and I put it in OEM costs of the base case, because there's a $34 a month fee that we just simply don't have to pay. So I'm going to enter this in as minus $34 times 12. And you'll see that comes up on the screen there. And that gives me a minus $408 a year in savings. And I just put it in the OEM. And you'll see with this now, okay, it's going to cost us money for the system, and after year 21, we're going to have a break-even situation with this PV system. However, there's still another advantage that's in the assignment, and that is to do grid-connected electricity. There's a startup charge, and if you're in a rural location off-grid, you're probably going to have to pay for a power line that gets you out, that gets the grid out to you. In this assignment, we said that this grid cost is going to be $14,210. In other words, it actually costs less for us to build the solar PV system than it is to pay the power, the initial cost to get the power grid out. So in this one here, incentives and grants, I'm just going to put in $14,210, because effectively that saving is something that's immediate. It's as if, now this isn't really a true cash flow anymore, because this $14,000 was a saving There was no cash transferred hands, but this shows you the economic analysis, is that by saving the $14,000 right away and making payments on the loan, the graph actually turns to primarily positive, where it goes down as you make payments and then you start to make money afterwards because you've really saved that $14,000. But if you want the actual cash flow analysis, you can enter that as a 0, and then you see the cash flow where you're $6,000 out for your down payment. You go down as you pay off your interest rates, and then you start to make money back as you get electricity and connect charges saved. And at year 21, the cash comes back. But in this analysis, remember, you're not dealing with that first $14,000. So this database then, this analysis can be saved. You file and save as. And generally you want to save it as a RETScreen file, which ends in an RET. And then when you load it, you can load it as a RET file, and you can kind of pick up that on that. So anyway, that's a quick overview of RETScreen, and hopefully that gets you started on the assignment.